Assalamualaikum warahmatullahi wabarakatuh. My name is Vindi Shafira from Mathematics Education League, Universitas Negeri Padang. In this video, I will explain about indefinite integrals. The objective is to solve the problems associated with integrality by using the theorem of integral. The content in this video is include definition, theorem, integration by substitution, and integration by parts. Definition: if the function f(x) is an antiderivative of fx, then each function with fx plus c, where c is an arbitrary constant, is called the indefinite integral of fx with respect to x, and then not as indefinite integral of fx. By this definition, integral of fx dx is fx plus c, where fx is called the integrand, x is called the variable of integration, and c is the constant of integration. From this, we know that integral is an inverse of derivative. Because integral is an inverse of derivative, so integral is also known as antiderivative. Theorem: there are 5 theorems for indefinite integral. Through this theorem, we can solve problems related to integrals. 1. Integral of dx equals x plus c. 2. If a is a rational number, then integral of a dx equals ax plus c. 3. If n is a rational number and n not equals minus 1, then integral of x upper n dx is equal to 1 over n plus 1 x upper n plus 1 plus c. 4. If n is a rational number and n not equals minus 1, then integral of ax upper n dx is equal to a over n plus 1 x to the power of n plus 1 plus c. 5. If fx and gx are functions, then integral of fx plus minus gx dx equals integral of fx dx plus minus integral of gx dx. Let's see the example. Evaluate the indicated example. From example 1, first step to do is change the form of algebraic vector into equation. So we get the integral of 2x squared minus 7x minus 15 dx. Then we need to integrate it one by one. So we have 2x cubic over 3 minus 7x squared over 2 minus 15x plus c. From example 2, we can start by completing the square equation of x plus 2 root of x all squared. So we get x squared plus 4x to the 3 over 2 plus 4x. And then change the denominator, the root of x, as numerator, that is x upper negative 1 over 2. After that, we finish the similarity by multiplying the quadratic equation with x upper negative 1 over 2. Then use theorem 3 for the next step. Finish the similarity by addition. After that, simplify the equation for the final solution. Theorem for trigonometric function. There are several theorems for trigonometric functions. This one is the basic theorem for trigonometric function. From example 1, we just need to integrate the trigonometric functions. From example 2, we have to use theorem 5 of the last theorem for x cubic and theorem 3 for sec squared x. For example 3, we do as example 1. In this theorem, a is constant, so to evaluate the integral related to this theorem, we just need to add 1 over a in front of the trigonometric function. For example, 1. Integral of sin 4x dx is equal to negative 1 over 4 cos 4x plus c. 2. Integral of 16 cos a half dx equals 16 over a half cos x over 2 plus c equals 32 cos a half x plus c. The example for this theorem are 1. Integral of sec square 4x squared plus p dx is a quarter tan 4x squared plus p in bracket plus c. 2. Integral of cos 3x minus 2 minus 9 sin 2 minus 3x dx is a third sin 3x minus 2 minus 9 over negative 2 cos 2 minus 3x plus c. It's equal to a third sin 3x minus 2 plus 3 cos 2 minus 3x plus c. In integrating trigonometric functions, the following formulas are often used. 1. Double angle identities. 2. Product to sum formulas. For example, 1. We have to simplify the form of sin squared x and complete the solution. From example 2, we have to factor cos squared x into cos squared x whole square, then finish up the simplest form. Integration by substitution. It's possible to transform a difficult integral to an easier integral by using a substitution. Integral fx dx is fx plus c. So, if u is g of x, then integral of x of g of x all composed with g prime of x dx is big F composed with g of x plus c. Example, integral of 4 plus 5 in bracket to the 8 dx. There are two solutions to find the integration by substitution. Assume u as 4x plus 5. du dx is 4. Therefore, dx is du over 4. The first solution is change 4x plus 5 into u and dx into du over 4. Then, complete the solution. Don't forget to express the final answer in terms of the original variable x. The second solution, integral of 4x plus 5 in bracket to the 8 dx is integral of a quarter 4x plus 5 to the 8 d 4x plus 5 equals 1 over 36 for x plus 5 all raised by 9 plus c. Integration by parts. If integration by substitution is failed, we have to use integration by parts. To use this formula, we will need to identify u and dv, compute du and v, and then use the formula. The theorem is, if u and v are a function which can differential, then integral of u dv is uv minus integral of v du. For example, find the integral of x sin 3x dx. According to the theorem, we have to assume u as x, therefore du is dx, and assume dv as sin 3x dx. So, v is integral of sin 3x dx equals negative a third cos 3x. Hence, integral of x sin 3x dx is negative a third cos 3x plus integral of a third cos 3x dx. This is equal to negative a third cos 3x plus 1 over 9 sin 3x plus c. That's all from me. Thanks for your attention. Assalamualaikum warahmatullahi wabarakatuh.